Jupiter and Saturn. These giant planets and the moons surrounding them will be looked at close up by two 1,800-pound spacecraft loaded with cameras and scientific instruments. A mission that allows scientists to go back in time and sample the conditions from which the sun and the planets, including the Earth, are believed to have formed.
In the vast silence of space, two lonely messengers from Earth are sailing into the great unknown. They're now farther from home than any object we've ever built, exploring a realm we're only just beginning to map. For nearly half a century, these probes have been our eyes and ears in the outer darkness. We sent them to what we thought was the edge of our solar system, expecting to find a clean boundary, a quiet place where the sun's influence just fades away into the galaxy. But what they found wasn't like that at all. There was no simple edge. Instead, they discovered a turbulent, chaotic frontier, filled with bizarre magnetic bubbles and a mysterious, superheated fog. They found a boundary that was alive, a place that shattered our theories and completely rewrote the story of our solar system's place in the cosmos. This is the story of what Voyager detected at the very edge of everything we know. Our story kicks off in 1977, a time of huge optimism for space exploration. NASA launched two of the most ambitious probes ever built, Voyager 2 on August 20th, and its twin, Voyager 1, just a few weeks later on September 5th. Their first mission was incredible in its scope. A grand tour of the outer solar system, made possible by a rare planetary alignment that only happens once every 175 years. This alignment let them use the gravity of one giant planet to slingshot to the next, like a cosmic game of pool. Voyager 1's first targets were Jupiter and Saturn. In 1979, it swept past Jupiter and revolutionized our understanding of the planet overnight. It sent back the first detailed images of its chaotic atmosphere and the famous Great Red Spot, a storm bigger than our entire planet. But the real stunners were found around Jupiter. Voyager 1 discovered faint, dusty rings we couldn't see from Earth. Even more amazing, it captured images of active volcanoes erupting on Jupiter's moon Io. This was a huge deal. It was the first time we'd ever seen active volcanoes anywhere besides Earth, proving that these distant icy moons weren't just dead rocks. They were geologically alive. It also gave us tantalizing hints that another moon, Europa, might be hiding a vast liquid water ocean under its ice shell. 2 years later, in 1980, Voyager 1 reached Saturn. It flew through the planet's magnificent rings, showing they weren't a few solid bands, but a mind-bogglingly complex system of thousands of individual ringlets, all held together by the gravitational pull of tiny shepherd moons. It peered through the thick orange haze of Saturn's biggest moon, Titan, and found a dense atmosphere full of nitrogen, more like a primitive Earth than anywhere else in the solar system. Voyager 2 took a similar path, but its journey was even grander. After visiting Jupiter and Saturn, it became the first and only spacecraft to ever visit the ice giants, Uranus and Neptune. In 1986, it flew by Uranus, discovering 11 new moons and 2 new rings. It found a bizarre magnetic field, tilted at a wild 60 degrees from the planet's rotational axis. This created a corkscrew-shaped magnetosphere that twisted and writhed as the planet spun. Then, in 1989, Voyager 2 hit its final planetary target, Neptune. It found powerful winds screaming across the planet's blue atmosphere at supersonic speeds and a colossal storm system called the Great Dark Spot. It imaged faint rings and arcs and flew by the strange moon Triton, revealing a frozen surface with geysers of nitrogen ice blasting into its thin atmosphere. The Grand Tour was a staggering success. It had completely changed our view of the solar system. But for the Voyagers, the mission was far from over. Their greatest adventure was only just beginning. After finishing their planetary flybys, the twin probes were flung into the vast, dark expanse beyond Neptune. Their cameras were powered down in 1990, but not before Voyager 1 turned back to take the iconic pale blue dot photo at the urging of Carl Sagan. Their new goal was the interstellar mission. They were setting out to answer one of the most profound questions in astronomy. Where does our solar system actually end? To understand their journey, you have to understand our cosmic neighborhood. The solar system isn't just planets orbiting the sun. The sun is constantly breathing out a stream of charged particles called the solar wind. This wind flows out in all directions at over 1 million miles per hour, carving out a huge bubble in the thin gas between the stars. This bubble is called the heliosphere, and everything inside it, all the planets, moons, and asteroids, is directly influenced by our sun. The heliosphere is our home. It's also our protective shield, deflecting a lot of dangerous, high-energy galactic cosmic rays that come from distant exploding stars. For decades, scientists could only guess what this bubble looked like. They figured that somewhere, way out in the cold and dark, the solar wind must eventually hit the interstellar medium, the gas and dust of the Milky Way galaxy. The boundary where the solar wind finally gets stopped is called the heliopause. This was, basically, the edge of the solar system, and the Voyager probes were headed straight for it. No one knew what they'd find. Most theories predicted a pretty clean, stable, and predictable boundary, a place where one environment just smoothly transitioned into the next. They couldn't have been more wrong. The journey to the heliopause wasn't a single step. It was a trip through a series of strange and distinct regions. The first major frontier Voyager 1 hit was a place called the termination shock. Now, it's important to know this isn't the final edge, but an internal boundary inside our own heliosphere. Think of the solar wind as a supersonic river flowing out from the sun. The termination shock is where this river suddenly and violently slams into the slower, denser gas of the outer heliosphere and abruptly slows down to subsonic speeds. It's like the shock wave in front of a supersonic jet. On December 16, 2004, after traveling for 27 years, Voyager 1 finally crossed this boundary, about 94 times farther from the sun than the Earth is. The data it sent back was immediately surprising. The solar wind, which had been racing at over 1 million miles per hour, suddenly slowed way down. The plasma got denser and much, much hotter. Voyager 1 had entered a brand new region of space, a turbulent buffer zone at the outer edge of the sun's influence. Scientists were ecstatic. They had finally reached the beginning of the end. But the spacecraft's instruments were also picking up something weird. The magnetic field in this region was way stronger than they expected, and it was behaving erratically. This was the first clue that the edge of our solar system was going to be anything but simple. This new realm was named the heliosheath, and it would turn out to be even stranger than anyone imagined. As both Voyager 1 and, later, Voyager 2 traveled through the heliosheath, that vast, turbulent region between the termination shock and the true edge of the solar system, they found something far more chaotic than any model had predicted. This wasn't some neat, layered region. They were flying through what scientists could only describe as a cosmic jacuzzi, a frothy foam of massive magnetic bubbles. And these bubbles weren't small. Based on the data, scientists figured these structures were enormous, some measuring 100 million miles across. That's roughly the distance from the Earth to the Sun. The probes would spend months inside one of these giant magnetic traps, then suddenly pop out into a different region, only to fly into another bubble. So what creates this bizarre foam? The answer is tied to the sun's magnetic field. As the sun rotates, its magnetic field gets twisted into a spiral, like a spinning dancer's skirt. When this twisted field is stretched all the way out to the heliosheath, it gets compressed and unstable. The magnetic field lines, which point in opposite directions, are squeezed together until they explosively reconnect, breaking up and reforming into a sea of self-contained magnetic bubbles. This was a profound discovery. It meant the outer layer of our solar system isn't a smooth, protective shield. It's a porous, churning, chaotic mess. This foam acts as a kind of particle trap. High-energy cosmic rays from outside our solar system can get caught in these bubbles, bouncing around for a long time before they either find a way in or get deflected. This complex process of magnetic reconnection controls how the interstellar medium interacts with our heliosphere, and nobody saw it coming. The Voyagers had shown us that the approach to our solar system's border wasn't a quiet shoreline, but a turbulent, frothing sea. And the biggest surprise was yet to come. On August 25, 2012, something incredible happened. Voyager 1, now 121 times farther from the Sun than Earth, detected a sudden, dramatic shift in its surroundings. The number of solar particles it was measuring dropped to almost zero. At the exact same moment, the intensity of galactic cosmic rays shot up to levels it had never seen before. After a 35-year journey, Voyager 1 had finally done it. It crossed the heliopause and became the first human-made object to enter interstellar space. 6 years later, in November 2018, Voyager 2 did the same, crossing the boundary at a slightly different location and confirming its twins' discoveries. What they found out there was stunning, and it came in 3 major surprises that challenged everything we thought we knew. The first surprise was the temperature. As Voyager 2 approached and crossed the heliopause, its plasma science instrument found that the plasma, the sea of charged particles, on the other side was way hotter than predicted, measuring between 30,000 and 50,000 Kelvin. Some have called this a wall of fire, but it's important to know this isn't heat you'd actually feel. The plasma is incredibly thin, millions of times less dense than the air we breathe, so the spacecraft passed through it completely unharmed. Still, the energy of these particles was unexpectedly high, pointing to a superheated boundary that we still don't fully understand. The second surprise was a magnetic puzzle. Scientists fully expected that once Voyager crossed into interstellar space, the direction of the magnetic field would change, shifting to align with the magnetic field of the Milky Way galaxy. But it didn't. To their astonishment, both probes found that the magnetic field outside the heliopause stayed stubbornly pointed in a similar direction to the field inside the Sun's bubble. It's as if the Sun's magnetic influence is somehow imprinting itself on the space just beyond its own boundary. This remains one of the great unsolved mysteries of the Voyager mission, suggesting a much more complex link between our solar system and the galaxy than anyone ever imagined. The final, and maybe most definitive piece of evidence was the particle data. Crossing the boundary was like flipping a switch. One moment, Voyager 1 was bathed in the solar wind. The next, it was gone, replaced by the much denser, colder plasma of interstellar space. At that same instant, the constant shower of high-energy galactic cosmic rays, which our heliosphere mostly shields us from, intensified dramatically. The probes had left the Sun's protective bubble and were now truly out in the galaxy, sampling the material between the stars for the very first time. Today, the 2 Voyager spacecraft continue their lonely journey, silent ambassadors sailing into the cosmic ocean. They're now nearly 50 years old, running on decaying plutonium that provides just enough power to keep a few vital instruments online. Their sheer longevity is a testament to brilliant engineering, but it's a constant struggle. In late 2023, Voyager 1, now over 15 billion miles away, suddenly started sending back gibberish. For 5 long months, the mission team was blind. The problem was tracked to a single corrupted memory chip in one of its computers. Repairing a chip from across the solar system was impossible. What happened next was an act of pure genius. Engineers at NASA's Jet Propulsion Laboratory came up with an audacious plan. They painstakingly sliced up the affected software and found unused corners in the computer's memory to store the individual pieces. Then, from 15 billion miles away, they sent commands to patch the code back together. Each command took nearly 23 hours just to get to the spacecraft, and another 23 hours to hear back. It was interstellar surgery. And unbelievably, it worked. By June 2024, usable data from all 4 of Voyager 1's remaining science instruments was flowing back to Earth again. The mission is a constant race against time and dwindling power. To save energy, NASA has been forced to make tough calls, shutting down heaters and, more recently, some science instruments. But they press on, still measuring the properties of interstellar space. Their instruments can even detect the vibrations of the interstellar plasma, data that scientists can turn into sound, giving us a sense of the faint hum of the space between the stars. Attached to the side of each Voyager is a golden record, a time capsule of sights and sounds from Earth, meant for any civilization that might one day find them. But the probe's true legacy isn't just what they carry, but what they've told us. They've shown us a solar system that is more beautiful, more violent, and more complex than we ever dreamed. And they've revealed that the line separating our home from the vast cosmos isn't a simple boundary, but a dynamic, mysterious, and awe-inspiring frontier. They are now so far away that their light takes nearly a full day to reach us. They will continue to drift through the Milky Way for millions of years, long after we are all gone, carrying the memory of a small, curious species from a pale blue dot who dared to reach for the stars.